Hi, this is Rishabh Goel, roll number 61, Chemical Engineering Batch 2018. I will be presenting this PPT on the topic of cetane number and octane number. Before getting right into the topic, we need to understand the reason behind defining cetane and octane numbers. Researchers found that even at same engine operating conditions, the possibility of knocking varies for different compositions of the same fuel. This created a need for establishing a standard to determine the fuel quality. For this, the quality of gasoline is measured in terms of octane number and the quality of diesel is measured in terms of cetane number. First, let's start with octane number. Octane number is the measure of the ability of the fuel to resist knocking. We can also see from the figure that as the octane number rises, fewer are the chances of the knocking. That is, the fuel can withstand higher compression without getting self-ignited. The name octane refers to a hydrocarbon which has 8 carbon atoms in it, that is C8H18. It was found that the fuel composed of only iso-octane produced minimal knock, so it was given an anti-knock index of 100. Meanwhile, the fuels made of pure n-heptane, a 7-carbon compound, that is C7H16, produced extreme knocks and it was given an anti-knocking index of 0. Hence, a mixture of iso-octane and n-heptane are taken as the reference elements for measuring octane number. As we can see on the octane scale, n-heptane lies on the 0th side of the scale and iso-octane lies on the right hand side 0th point of the scale. So by definition, we can say that octane number is the percentage of iso-octane present in a mixture of iso-octane and n-heptane. A fuel is tested for knocking and an octane number of a particular mixture of iso-octane and n-heptane that produces the same amount of knock at similar conditions is assigned to it. That is, the fuel of an octane number 85 indicates that it produces the same amount of knock which is produced by a fuel with 85% iso-octane and 15% n-heptane. In India, regular petrol is rated at 91 octane number. The octane number does not represent the fuel composition. The octane rating of a good gasoline ranges somewhere between 85 to 90, and some fuel may even have an octane number greater than 100. As the working condition of the engine changes, the chances of occurring of knocking varies. Based on the engine working conditions, there are two different ways to measure the octane number. First is the Research Octane Number and another being the Motor Octane Number. First, let's start with Research Octane Number. The octane number measured by experimenting fuel in the engine running under mild loads at low speed is Research Octane Number, and the octane number measured by experimenting fuel in the engine running under heavy loads at high speed is called Motor Octane Number or MON. Generally, the Research Octane Number is indicative of driving in the city, that is at low speed about 500 rpm, whereas the Motor Octane Number MON shows the working ability of engine at circumstances with higher rate of about 800 rpm. The average of these two is known as the anti-knock index. It can be easily given by the formula of Research Octane Number plus the motor octane number and divided by 2. The octane number of the fuel is given in Research Octane Number scale in European countries, whereas it is given in anti-knock index in the United States. The difference between the Research Octane Number and the motor octane number is known as the fuel sensitivity, which shows how sensitive the fuel is when the engine operating condition changes. It usually ranges from 8 to 10. That was all about octane number. Now let's discuss about cetane number. Cetane number is the measure of quality of diesel fuel, which indicates how fast the fuel can be ignited. Standard compounds used as a reference for cetane number are cetane or hexadecane and 2-methylnaphthalene. The cetane rating of cetane is 100, that is, it can be ignited instantaneously, and that of 2-methylnaphthalene is 0, which denotes that it has long ignition delay. We can see on the CETANE scale that 2-methylnaphthalene lies on the most left side part of the scale and cetane lies on the rightmost part of the scale with a value of 100. The cetane number can be defined as the percentage of cetane present in the mixture of cetane and 2-methylnaphthalene. Cetane number of fuel is given by testing the fuel and providing a rating of the mixture of cetane and 2-methylnaphthalene, which produces the same amount of knock at similar conditions. Iso-cetane, a structurally different compound of cetane with cetane rating of 15, is nowadays used instead of 2-methylnaphthalene, which could not be handled safely. As we can see on the CETANE scale, iso-cetane lies at 15 value. We can see from the figure, as the cetane number increases, the ignition delay decreases, which means fewer chances of knocking. Examples of high cetane numbers are long chain saturated unbranched hydrocarbons, while components such as unsaturation or branching leads to that of lower cetane numbers. Fuels with higher cetane number are more efficient. They also result in increased output, higher efficiency, reduction in odor and noise emission. Certain additives can be added to the diesel fuel to enhance their cetane number, but it adds to the toxicity in the fuel. Concluding what we have studied so far, we can say that the octane number represents how much compression a fuel can withstand without getting ignited, and the cetane number can be described essentially as the contrast of the octane number, and it measures the ability for auto-ignition. That is, the cetane number represents how fast the fuel can be ignited. In Indian scenario, petrol has been given a rating of 91 octane number and diesel has been given a rating of 51 cetane number. That will be all. Thank you.